All right, guys. We're going to start going over this thing together. Let's see, 1A, I think almost everybody I looked at pretty much got that one right. What's the first thing you want to do on 1A? Right? Yeah, I wish we'd never come up with radical notation. It's stupid. Almost every math thing you have to do, you have to first make the radical into a fractional power. So why did we come up with it? So first thing, rewrite this sucker. Then this is stuff to the 1/5 power. Stuff to the 1/5 power. The 1/5 power comes down. It goes down by 1, right? So whenever the inside is more than just x, chain rule comes into play. In fact, you guys are aware that chain rule always happens. What's the derivative of x squared? 2x times the derivative of x. And of course the derivative of x is 1. Okay, beautiful. So hopefully most of you teachers kind of pointed that out. And chain rule never doesn't work. It only just sometimes changes because a lot of times it's just 1. So it doesn't do shit to us. So here the 1/5 comes down. Stuff is now to the -4/5 power. By the way, in case your instructor never pointed this out, we're not done with this, but when you have to subtract 1 from any fraction in the entire universe, you take the top minus the bottom, put it back over the bottom. Right? So 1 minus 5 is -4, put it back over 5. Done. Yes? So if you have like x to the -11 over 81, you're like, what the shit? Well, you just take -11 minus 81 is -92, put it back over 81. Easy. Okay. What's the derivative of the inside? Holy shit. Okay. There's really nothing you could do to simplify that, so that's fine to stop there. Okay. This one, I feel bad for you. It's perfectly legitimate to do 1 over this times the derivative of this, but dear God. So those of you that took my 180 class, you've heard this many, many times. What do you do before you attack a function with calculus? Simplify. So before you attack a function with calculus, just simplify it. Yes? I got all this shit to do something to. Well, does some of it cancel? Does some of it break apart? Right? So before I do some freaky ass thing to something, I'm like, can I make you better first so that the freaky shit is easier? Yes? So can you factor the inside? Yes, no, maybe so? What's the top become? Huh? W minus 1? W plus 1? I mean, you can make it y if you want to, I guess, but... And then on the bottom, take a 2 out and you get w plus 1, so the w plus 1s cancel. And then I could do this, if I wanted to, using properties of logs, yes? The log of a quotient is the difference of the logs. And then the derivative is dumb. What's the derivative of this with respect to w? 1 over w minus 1. What's the derivative of this? Careful, careful. What's the derivative of a number? 0. Done. That's a constant. It's a freaky looking constant. I don't give a shit. Where are my 180 students? You know I've done this before. I say, what's the derivative of e to the 5th minus 7 e to the 4th divided by natural log of 7? The derivative is 0 because all that shit's a number. Yes? Okay. I don't do that too often. It's a little tricky, but just pay attention to what's going on in the function. Constants can look really trippy. Is everybody with me so far? Okay. Nothing too crazy. So you got to remember your logarithmic properties. Trust me, just always, eternally. Factoring is huge everywhere. You know, the minute you learn factoring, you're like, how to do anything before I knew the factor. Trig identities, I've already talked about, is very important, but that hasn't happened yet. This one is just a very, very direct application of everybody's favorite quotient. Yes? What's the song? No, the song is top first. That's the song. I don't like Heidi Low crap. That's bullshit. But if you like it, fantastic. Real quick. I don't think you guys have ever seen this. If I have f over g, yes? Don't write this down, just watch. And I want to take this guy's derivative. Isn't this f times g to the -1? You with me? So how do I take the derivative of a product? Derivative of the first guy times the second plus first guy times the derivative of the second, yes? How do I do stuff to the negative 1 power? How do I take that derivative? The negative 1 comes down. Yes, don't freak out. You can do it. Negative 1 comes down in front of stuff to the negative 2 times the derivative of stuff. That's just chain rule, yes? Stuff to the negative 1. Negative 1 comes down, negative 2 power times derivative of the inside. Whoop-de-doo. Isn't this f prime over g? Yes? And isn't this, let's see, this will be negative f g prime over g squared, yes? How do I combine these? Make like denominators. So I get f prime g minus f g prime over g squared. This looks very familiar, yes? Yes? Okay, sorry. Anasha. No, that's what it is. That's one derivation of quotient rule is that. Okay. So here it'll be derivative of the top is 1 times the bottom minus derivative of the bottom is 2x times the top all over the bottom squared. And then you just have to distribute, get your like terms together. X squared minus 2x squared is negative x squared. And then I get minus 4x minus 3. I think that's right, yes? You guys, anybody get that? Yes? Okay. So either we're all wrong together or it was right. Okay. As long as we're all wrong together. Okay. Good old quotient rule. Is everybody with me so far? Okay. And then this guy. Oh, shit. I always get people trying to write it sine and cosine and do all this weird shit. I don't know what the hell the integral of tangent square. I don't even know what the integral of tangent is. I do, actually, but you'd have to rewrite it. What is tangent squared x plus 1? Yeah, so identities. Anytime you see a squared trig function and you're like, I'm not sure what to do, think Pythagorean identity. Yes? You with me? Because maybe that'll make it something you can do something to. And sure enough, this is like just about impossible. But that equals this, and this is stupid. What's the integral of secant squared? Tangent, because that's what derivative becomes secant squared is tangent. So plus 1, Jeff. What the hell is that? You guys with me? Okay, so trig identities will save your ass. Unless you don't know them, and then, oh well. Did anyone identify the method on part B? U sub all day long. Classic U sub is there's a function stuck somewhere, and the derivative of that function is in there, except the constant might be wrong. I don't give a shit about constants. Constants dance the way we want them to. Yes? So the derivative of stuff y squared is stuff y. I have the y squared stuff is stuck, the y is free. That's what I need. So when will U sub work? 100% of the time U sub works if there's a function in there whose derivative is in there also. 97% of the time, it's if there's a function stuck somewhere whose derivative is in there also. Yes? So this is one of those classic ones. 2y squared is stuck in the power of e, but its derivative is what specifically? 4y. dy. Do I see this in here? Sort of, but what's extra? 2. So I take a factor of 2 out. Do I see 4y dy? Yes. I swear to God, if your teacher showed you this, it's not your fault. Just, I want you to know that they're wrong. That's very blunt, sorry. It's not wrong. It just leads to easy mistakes. Don't solve for dy, don't. Just make it so you can find what you need. How do I put du in? Well, I have to find 4y dy so I can replace it, yes? That's a skill in itself, balancing what you need. That's a skill that if you don't get enough practice for it, when you go further in math, you're going to suck at some other things. So I always hate it when I have my colleagues have you solve for dy. It's not that hard to balance things. There's too much, take a 2 out. If there's too little, put a 1 over so you can put the thing inside, yes? I'll do a problem like that in a minute. So if this is du, this is going to be e to the u. And what's the integral in it? e to the u. And what was u? 2y squared. Oops. Yeah, I know, you guys can almost sit sideways and just watch that thing. Yeah, I gotta talk to them. I want this front stripped so there's not as much glare, but oh well. I can't make that light turn off. You guys with me? You guys remember U-sub? It's crazy important you remember U-subs distinctly because the first method of Calc 2 is gonna look a little bit like U-sub. And the less comfortable you are with U-sub, the more you're gonna mix the two, and that's gonna suck. We use the letter U and another letter in the first method we learned in Calc 2. And people kind of mix these two things up, and that sucks. So the better you know U-sub, the more distinct you can make it from the first method we learned. Does that make sense? A little bit, okay. If you're not good with U-sub, that's another thing you want to focus on immediately. Now, what about this one? What's the biggest difference between these integrals that we just did and this one? This is a
general antiderivative.
Yeah, this is a indefinite, this is definite. So these represent antiderivatives. What does this represent?
A single value.
Huh? What's second? Area. I like it. Area. So definite integration represents area the same way that derivatives represent slope. Yes? Did anyone do this problem? What was your first step?
U-sub.
What'd you let u equal?
Pi theta.
Good. And then what's du?
Pi.
Pi
Pi
d theta. Okay. Not a bad idea. Can I see pi d theta in there? Kick ass! I don't have to balance anything. I've got pi d theta already. I'm going to leave these blank for a second. So this will be, that becomes du. This will be sine of u. Now, why did I leave these blank? What do I have to do with those?
Either keep it the same or you can change it.
Yeah, because what do these numbers represent? What's 1/6 and 1/2? What do they represent?
The rate and the
What does that mean? The bounds for what?
For the area.
Don't say the integral or the area.
for the original
I
function.
need something more specific. What axis does 1/2 or 1/6 live on? Nope, I don't see an x in there. Theta. Good. So what is 1/6 and 1/2? They are what theta is doing. These are the numbers that tell me what this thing is doing. Yes? What letter do I have now? Oh shit! If I put numbers on that interval I just wrote, they better be what u is doing. How do I know what u is doing? And how do you know that I know grammar after I just said that statement? What is you doing? What is you doing? Okay. What is the value of theta at the least? 1/6. What is u when theta is 1/6? When theta is 1/6, what's u? Pi over 6. When theta is 1/2, what's u? Pi over 2. There you go. Now I don't have to bring theta back because the area of this is the same as the area of this. If I had a rectangle and then it has an area and I smushed it and made it taller and less wide, it would have the same area. Yes? It just got smooshed up. That's what this is doing. Believe it or not, it just says this area is the same as this area. That's kind of neat. Okay. What's the integral sign? Negative cosine. And I want to go from pi over 6 to pi over 2. What's the cosine of pi over 2? No?
0.
Yes. What is cosine like? By the way, if you know SOHCAHTOA, I apologize again. SOHCAHTOA sucks. Cosine likes x, sine likes y. Sine is biggest when you're at 90 degrees. It's minimum when it's at 270 because that's the y-axis, yes? The 1, negative 1. Cosine is 0 there because there's no x piece when I'm all y. The minute I move away from that, now I've got a bit of an x piece. I've got a shadow, yes? Okay. That is the best way to learn trig. So SOHCAHTOA helps you with one thing for a little bit. Cosine likes x, sine likes y helps you through everything. Physics, math, all the other shit. Okay. Cosine of pi over 2 is 0. What's cosine of pi over 6?
Root 3 over 2.
Because 30 degrees, right? Pi over 6 is 30. Is that closer to the x or the y? So cosine should be bigger, rad 3 over 2. Cosine of 60, it's far away, it's closer to the y. Cosine should be smaller. Cosine of 60 would be 1/2. Okay, that's how I remember the stupid values. Instead of just straight memorization, cosine gets smaller the closer I get to the y-axis because cosine likes x. Yeah. Okay. So then I get rad 3 over 2. Neato. Okay, so as long as you change the limits, you don't have to bring the original variable back. If it was an indefinite integral that I did u sub, you have to bring the original variable back, or else you're answering a question I didn't ask. Okay. I went a little quickly. None of you guys had any questions, apparently. Any questions on any of these? Yes?
Can you repeat what you said about bringing the interval down? That you don't have to change the list. Sorry, can you repeat the last thing you said about...
Oh, if it was an indefinite integral, you can't have your answer be related to u. Your answer has to be using the variable in the question. Does it make sense? If it was an indefinite integral, here. If I had the same problem, well, screw that. If I had a problem like this, we'll do this, yeah. Indefinite, yes? So then I'll let u equal 2x, du is 2 dx.
You gotta slide to the left a little bit.
Thank you. Yes? I can't stop there. This is wrong. Because the u thing made my work easy. Have I answered the actual question yet? No, I have not. I made my work easy. I'm still in work phase. I have not answered the question. What's the answer?
We'll use 2
Sine 2x.
Now I've answered the question, because the question dealt with the variable x. If my answer doesn't have the variable x, it's not the answer yet. It's still in work mode. So when we do u sub, we're making the integral look better. So my middle part, the work is easy. To answer the question, you better give me the same variable in the question, or else how could that be the answer? You guys with me? Really easy things to forget, especially when you have a more complicated integral. But just make sure if it's an indefinite integral, your end variable better be the same as your initial variable. Some of you guys don't look at me like I just spoke Greek. And I did say theta earlier, which is Greek, but I guess officially I did. Are you guys alright? Y'all look stunned. Is everybody okay? So listen, I desperately we did a decent amount today, yes? The purpose of the sheet I just gave you was not to make you feel bad if you forgot some of this stuff. It was a diagnostic. I'm not going to look at this sheet. You're going to go, hopefully, see me during office hours, to go see somebody in the CISL, see somebody in the MSE, and say, hey, my crazy ass professor gave us a dumb sheet here. I don't remember this at all. Can you help me remember this stuff? Bam. Yes? If you don't have time for any of that, email me. I can Zoom people, right? It's not the best way to do anything, but I can Zoom with somebody. I know some of you have jobs and stuff, and you're like, I am only on campus for class. Like, oh, okay, then I'll Zoom with you. Just, you gotta let me know. Okay. I think that's good. I'm gonna let us out a little early. We normally go till 9:15. We're actually not normally gonna go to 9:15. If you have any questions or anything, stay after class. Otherwise, I'll see you all Thursday.